6-7 is solving radical equations and inequalities, which in Algebra 1, you have done solving radical equations with square roots. We're going to look at square roots, cube roots, higher roots, and also, like it says, inequalities. So there's some important things to remember. When solving an equation, we want to get our variable alone. Therefore, if a variable is under a radical, we need to undo that radical. We need to get rid of it. So we use the inverse. The inverse of a square root is to square it. Now just remember, if we square one side, we have to square the other side. To get rid of a cube root, we must cube it. And same thing, if we cube one side, we must cube the other side. If it's a fourth root, then we raise to the fourth power, and so forth. Okay? There are times, though, when you solve a radical equation that will yield an extraneous solution. So you'll do all your calculations correctly, but the answer is actually extraneous because it may give a negative value inside, which can't work. So let's try some of these together, and I'll have you try some on your own. So for number 1, we're just going to try to isolate our variable. So we will subtract 7. I now have 2 root x equals 4. Divide by 2. We have root x equals 2. And now we have that radical alone. That's our whole goal, is to isolate that radical. So now we can square it to undo it. And if I do that to the left side, I must do it to the right side. So we get x equals 4. Now, here's where we must check, okay? This is not just did I do it right? We may have done all of our calculations right, but there could be an extraneous solution. So always go and check. So if I plug that 4 in, does it actually equal 11? So we would have 2 times 2 plus 7. And yes, 4 plus 7 is 11. So that is good. So it means x equals 4 is our solution. Okay? I'm going to jump now to number 4. So you can try 2 and 3. Again, make sure that you check those extraneous solutions. On 4, notice we have a cube root. Don't let that throw you off. We're still going to just isolate that radical and isolate the variable. So the first thing we're going to do is get rid of that 3. So we'll add 3. I now have the cube root of 4a minus 1 equals 3. Now that the radical is alone, we can get rid of it. So to undo a cube root, we will raise it to the third power, which means we must raise 3 to the third power. We are left with 4a minus 1 equals 3 to the third is 27. Now I will add 1 to both sides. 4a equals 28. And now divide by 4. A equals 7. This time around, it's not as important for you to do the check because we have a cube root, and having negatives is okay inside. But just out of habit, we may as well, and then you can always make sure that you're actually doing it correctly as well. So we want to know, does the cube root of 28, right, 4 times 7 minus 1, and then minus 3 equals 0. So we get the cube root of 27 is 3, and 3 minus 3, yes, that does give us 0. So a equals 7. All right, let's keep on going. I'm going to do 6 and 8 with you, and you'll try 5 and 7. So if you notice here on number 6, we have 2 radicals. When there are 2 radicals, you want to make sure that they are on each side of the equal sign. So one stays on the left side, and then one goes to the right side. In this case, I'm going to move over the second one because I like to have positive radicals. So now I will have the square root of x plus 8 equals, and because that's a negative 3, I'm going to put that afterwards. So I'm going to have the square root of x plus 35, and then minus 3. Once we are at this point and we've isolated one of those radicals, I'm going to now square both sides. So to undo that radical on the left, I square it. So I need to do that on the right. However, notice this is a quantity, right? There are two terms here. So when I square that right-hand side, square the whole quantity, which really means we are going to FOIL. So just right next to it, I'm going to rewrite that right next to it so that when I FOIL, we don't miss anything. Okay, so that left-hand side, very easy. Square root cancels. I'm left with x plus 8. The right-hand side, we now need to FOIL. So root x plus 35 times root x plus 35, those roots will just cancel and we're left with what's inside, x plus 35. Now we do the outside. That's going to give me minus 3 root x plus 35, right? One is a radical and one's on the outside, so we don't put them together. And then we do the inside. You get the same thing, minus 3 root x plus 35. And then lastly, negative 3 times negative 3 is positive 9. So now let's clean that up. So this gives me x plus 8 equals x, 35 and 9 makes 44. And then minus 6 root x plus 35. Now what we have is a radical equation still, but just one radical. So I want to treat this like the beginning problems. We want to get that radical alone. So I'm going to move the x and the 44. Please take a note. I'm going to use a color real quick. Please know that we cannot combine those two terms. That 6 is attached to the radical, so make sure that you don't mistake that and combine those two terms. Okay? So I'm going to move this x and this 44 to the left-hand side. When I do that, I get 8 minus 44, which I kind of like the looks of that because that's giving me a negative 36. And on the right side, I have this negative 6 root x plus 35 left. So I like that negative 36 because now I can divide that right-hand side by negative 6, and it comes out as a nice integer. Negative 36 divided by 6 is positive 6. And it's really important to notice we're even at this point right here, okay, we have this positive square root equaling a positive number. So that's good. If I had a negative, that should kind of be a red flag to you of, well, I could never have a square root being negative. So now we have this radical all the way alone. So to undo the radical, I'm going to square both sides. So now we have 36 equals x plus 35. And so last but not least, I'll subtract 35. This gives me 1 equals x. Now, after I find that answer, remember we must check. Okay? So hopefully all that work was worth it, but let's see. So I'm just going to do the check up above. I'll do that in light green just to save some room here. So this would be saying the square root of 1 plus 8 minus the square root of 1 plus 35. And we want to know, does that equal negative 3? So 1 plus 8 is 9. The square root of 9 is 3. 1 plus 35 is 36. The square root of 36 is 6. So is 3 minus 6 negative 3? Yes, it is. So all that work paid off, and x equals 1 does work. Okay, how about number 8? So for number 8, don't let this throw you off. I see a rational exponent. But rational exponents really are just like radicals. You could think of this as the cube root. Or we can just solve with the rational exponent. So the first thing I'm going to do to get y alone is I'm going to subtract 5. So now I have the quantity of 3y plus 1 to the 1/3 equals negative 5. Now what I want to do is get rid of this 1/3. Well, we've done this before, but you can also think about 1/3 as I convert that to radicals as really a cube root. So what would I do to undo a cube root is that we would raise all of that to the third power. Or how would I make that exponent become a 1? I multiply by 3, right? 3 times 1/3 makes a 1. So if I do that to the left, I must do it to the right. Remember, you're raising that whole -5. So we now have 3y plus 1 equals -125. Subtract our 1. 3y will equal -126. And now we divide by 3. And that gives me -42. Again, not as imperative that we check here because this 1/3 is a cube root. So extraneous values don't show up as often because it's okay to be negative. But we can double check that. So I'll do my check in green. And this would be saying 3 times -42. Oopsies. Let me just get rid of that. Plus 1 to the 1/3, and plus 5 equals 0. So 3 times -42 gives me -126. -126 plus 1 gives me -125. So this is saying -125 to the 1/3 plus 5 has to equal 0. Remember, that's really saying the cube root of -125 plus 5. That is -5, and -5 plus 5, in fact, is 0. So our solution is, in fact, correct. Okay, so go back to the other equations and solve those. And always, like I said, check your work to make sure you don't have any extraneous solutions. If you do plug something in and it doesn't work, then that means it's an extraneous solution and you will exempt it from your solution set. Okay, now let's look at one of our inequalities, and I'll have you try one on your own. So for inequalities, what you need to remember is, of course, when we multiply or divide by negatives, it flips the symbol. But also remember, for an inequality, it'll give you multiple answers. So you may get something that says x is greater than 7. So that means 7, 8, 9, 10, 11, 12, etc., right? Or x is less than, and so you have a wide variety of answers. What you need to remember, though, is that we need to check the domain, because maybe one of those answers in your large solution set could create a negative on the inside, and we can't have negatives on the inside of square roots. Cube roots is fine, but of our square roots, that would become imaginary. So there's 2 aspects of this problem. We're going to solve it as is, but we're also going to check the domain. So let's start with checking the domain. For our domain, you can think about, which we've done this before, right? We can think about what our shifts are and so forth. But the main thing is it's asking us inside here, we can't have that be 0. So my domain has to be that what's inside of my radical has to be greater than or equal to 0. So we're always going to set what's inside that radical greater than or equal to 0 for my domain. Okay? That's telling me any x value that's greater than 0 or equal, so anything that's positive, will be okay. So I'll solve that. I'll add 10. 5x is greater than or equal to 10. Divide by 5, x is greater than or equal to 2. So I know that no matter what, my numbers that I get have to be greater than or equal to 2. Now I actually go do the solving part. So now I'm going to rewrite this problem. 3 plus the square root of 5x minus 10 is less than or equal to 8. We'll solve, so I'll subtract 3. We get the square root of 5x minus 10 is less than or equal to 5. Now I will square both sides. So we get 5x minus 10 is less than or equal to 25. I'll add 10, so 5x is less than or equal to 35. And then I will divide by 5, which gives me that x is less than or equal to 7. So if I had just done the solving, I would have gotten that x is less than or equal to 7. However, our domain says, but wait a second, you must also be greater than or equal to 2. So therefore, my solution for number 9 is I have to put those together. So it's x such that x is greater than or equal to 2, but less than or equal to 7. If when I solved, I had gotten x is greater than or equal to 7, then that would have been totally fine because anything greater than or equal to 7 also passes the test of greater than or equal to 2. But in this case, we need to combine the two for my solution. Okay, you try number 10.